Okay?
Okay.
Good.
Okay. Some of them, as I say, contains errors. So this is really badly written.
Yeah, I don't really remember doing these papers that much, so it's all blank for me, especially these ones.
Okay. So what do you think about this one?
So, isn't this a C, right?
Seven?
C.
C. Why is C?
Just like nano is always just learned to be -9, and you know nano's smaller than micro, but bigger than pico.
Mm-hmm. This is see. This is a quite easy one. Mm-hmm. How would you solve this one?
I think so. So 4.
This actually ones which actually I'm not sure about the result. How would you try to solve it anyways? How do you try to solve this one? Yeah,
I'm thinking.
I think the question here is dubious. Is badly done.
So what is F? Okay.
So the best thing to think is scheme weight. So you have first a triangle, right?
Mm-hmm.
Yeah. And here there is. So you in this part of the triangle you have a weight of 10 kilonewtons and another force in this base of the triangle, which is actually we don't know. We don't have friction, so it doesn't matter. Well, it's badly done this triangle, but okay. How then do you solve this triangle scheme? So you have actually one force going to the opposite to this one.
Yes, yeah. Okay.
But if you see there's you have an angle here.
Yeah, 30. So.
It's just a balance of forces. How would you solve that?
Humble equation for it. Sine theta.
So this is
Sine.
this is as you see the force is here, right?
Yeah.
This is the angle, and this is the other force going there. So, and this is the base of the triangle. Really doesn't matter. So what you need is you have a component of this force. So well, this force is in totally in y. If you see, this is x, this is y. So this is a vertical force, and this is going in both directions, as horizontal and vertical.
Yeah.
So what we need is, and the actual force is going in the opposite direction. What it needs is f of y. So how can you calculate f of y? I mean, it's still part of this force, but only the part that go in the vertical direction.
Okay.
So if we consider two axes, every vector will have an x component and a y component, right? So, but if this one is totally vertical, so it doesn't have a real x component, only a y component. So here f is equal to the f of x plus f of y. And this one is only f of y. Not exactly this f, we'll call it g of y. And this g of y must be equal to f of y.
Okay.
For the system to be in balance.
Yeah.
To actually do oppose.
So you need to find f of y first. Find f. Okay. So
So this thing is, so f of y, so it's a triangle. The base of the triangle is the g of y. This is the theta, and this is the hypotenuse, right? So when you have the hypotenuse, the adjacent side of the triangle and the angle, so how can you call it?
What do you mean?
So you have a triangle.
Yeah.
You have here your angle. You have the hypotenuse here. And you have the adjacent. So if I want to calculate the, for example,
Socotel trig.
so if I want to calculate the sine or
So it's cos.
or the cosine, what do I need?
So you need to use cos theta.
Both of them are over?
Yeah, well, it's a over h, yeah.
So sine is?
So a over h.
Is opposite or adjacent?
Adjacent.
Same.
Oh, wait. Yeah, opposite. Sine is opposite, yeah. Then cos is adjacent.
So what actually, so now here, if you see here, you have a triangle. This h is f. This adjacent is what I call g of y, and the angle is still the angle.
Okay, so you need to.
So here you have, you have f. So if we said that the cosine of theta is equally to a over h, but we say that a is
A is gy. H is f.
H is f. So what actually, if I need f, I want pass to the other side.
Yes, you need to rearrange it.
So f is equal to
The inverse cos. Yeah.
And you have 10 kilograms.
So you replace gy with 10, and yeah, that's how you find it. And replace theta with 30.
And 30. And you should have the result, but it's supposed to be, I don't know, it's supposed to be D.
D, okay.
Now we see something.
Okay, so that's just converting from base units to FI unit, SI unit, base units. So, yeah.
So here what you have to do.
So you have to convert each one into their base units, into their SI units.
Both of them are SI units. But the only thing you have to convert is J.
Okay.
So what is the value of J? So it's energy. How do you calculate energy? For example, kinetic energy. What is the equation of the kinetic energy?
Half. Something. M. It's not mg.
M?
Yeah. So half some m. Is it mg squared? No.
B squared.
mv squared. Oh.
Yeah.
Because gravitational potential is mgh. Sure.
Energy potential is
mgh.
mgh.
That's why I got confused.
Well, anyways, so any unit of energy. So we can use both. So mass is in?
Mass is in kilograms.
In kilograms. So the gravity is an acceleration. How do you calculate acceleration?
It's meters per second.
Minus 2.
Squared, yeah.
And h?
Is meters.
Meters. So in total, energy, for example, the potential energy is kilograms. You have 2 meters, so meters squared. minus 2. Mhm.
Okay.
But you also multiply kilograms minus 1. So
it's just
for example, this is everything. This is called U. This is the value of the U. Kilograms meters square second minus 2.
Okay.
So when you replace, for example, U, you will have kilograms meters square second minus 2 times kilograms minus 1.
K minus 1.
K minus 1. This one, with this one, eliminate. And you have
M squared S to the minus 2 and K to the minus 1. So C.
Yep.
Diffraction uncertainty.
Yeah, the only thing is they, instead of using the units, the typical units, you use only the base units. Remember that the base units are just those ones who actually measure. So joules, you cannot measure exactly joules.
Okay.
You can measure a meter, you can measure a kilograms.
Yeah. I'm not sure how to do this question. I've really bad at these types of questions. Fractional uncertainty. I don't know how to do it.
So if you have, this is the value, right? For example, let's say 3 minus 0.5 x, for example. So the big X is 3, the small x is 0.5. The big y is 4 minus 0.4. This is the big one. This is the small one. So when you have division, well, first potential. So this is small y. When you put the big Y to a square, this one is going to be y squared. This is going to be 2 times.
Okay.
And when you have, for example, x over y, you will have these are the one. You will have to do the small x plus 1.
Okay.
If you divide, and if you do x times y, the big quantities, you have to do the same x plus y. Doesn't matter if it's dividing or multiplying.
Okay.
You have to add them.
Okay.
So, how do you solve then this one?
So, when it's x plus 2y.
X plus 2y, it will be again same. Question 5.
Oh God. So,
You're putting the time, right?
yeah. Which statement is correct?
You have a normal circuit. For example, I will put the battery here. And you just measure from this point to this point. So, what do you measure in series and what do you measure in parallel? So you have two devices. Usually the
Ammeter and voltmeter.
And the ammeter and the voltmeter. Which is in series and which is you put in parallel. When you measure,
Ammeter is series, voltmeter is parallel.
so what will you measure here?
So that's volts. But that's the voltmeter you use.
So the question is, the voltmeter, what is the voltmeter?
So we need the 0, which is correct. There's no volt. No, I think it's maybe B, D, I mean.
Now you have to.
There's no resistance. I'm not sure.
No. You have to measure. So forget about this. Because, I mean, maybe. So you see, you put two cables in parallel. So you cannot read the resistance. So you have the voltmeter we said, right? So not an ammeter. So you have to measure potential difference.
Okay. And it's very.
Now it says that it's 0. So if it's 0, what does it mean?
And the potential difference is 0 as well. And
Exactly, yeah.
okay.
Yeah. Yep. So there is no such thing as a potential difference of like infinite. But yeah, not in that way.
Object is of initial velocity unit acceleration A, moves in a straight line through S and has V. Which condition must be satisfied in order for this equation to apply to the motion? So it's not B, not C. Yeah, I think it's C.
Same.
C, yeah.
It's question 6, right?
6, yeah.
Why C?
It seems logical to me. That the magnitude A will always be constant. The direction has to be constant as well for it to be in motion.
So analyze first. So you have an object. And you have a velocity. Velocity is a vector.
Yeah.
So you have a magnitude, a direction. So the direction is this one, and a sense also. Sense is where you put the arrow. And also you have an acceleration. So what it only tells you an acceleration, the object moves in a straight line. So this is a straight line.
Yeah.
So the acceleration cannot go. Well, yeah, it can go, but you need more forces. But the acceleration has to be also in the same, some sort of direction. So, but which is the sense? So, where the arrow should go? In this way?
No, other way.
Not necessarily, because it doesn't tell you the acceleration can go.
You can go anywhere.
Can go, and practically what you can do is so this one could be acceleration, and in reality could be. So even when it's negative, so it's an acceleration.
Yeah. Okay.
So your velocity could be here, and your acceleration could be here. So it's not necessary to be in the same direction.
Okay.
So it's the direction of the constant.
Yeah. So it can't be A, and it can't be B.
Well, I mean, if so, the direction could be.
It's just elimination, really, finding out what's wrong.
So it's this.
So it can't be B because if it can't use not direction, it's initial velocity, so it's not moving. So if it's for the motion, there has to be motion, and U there is no motion. So if A is in the same direction as U, there will be no movement. As U is not moving.
Not necessarily. So.
Okay.
So it says that in order to be satisfied the equation, so you have to fulfill some condition.
Start on the next one.
Okay. You don't want to take it?
No, it's fine. I'll try to get this open up with this paper.
So actually, it doesn't really matter. So you can. This could be true, but it's not necessary. The same as this one. So as I said, the acceleration could be also in this contact, and it could be still satisfied. So it could be here, or could be in this direction. Could be either. So it's not necessary that it has to be the same this one. The thing it's only necessary is that the magnitude of A should be constant.
Yeah.
Otherwise, this equation would not
No,
be.
it doesn't make sense.
It wouldn't
Will
be
be
true.
satisfied.
And also this one is the same. So U and B is
Yeah.
the same.
The car is traveling at quantum velocity. Uniform deceleration. This would be A, right? I'm sure pretty sure this would be A. It's uniform deceleration, so it's constant deceleration.
Mm-hmm.
So it'd be A.
Why not B?
It doesn't show deep. It does show constant, but
It looks like more like a constant.
yeah. That's true. Can't think of the word for it, and I have it in my head, but I can't think of the word.
So what are the units of this one?
V, that's velocity.
Meters per
Second here.
and this
Meters.
Meters. What acceleration has? It has meters per second square. So this is a line. And this is the effect of the acceleration. But if you see, acceleration is a square respect with the time. So you cannot expect a line here. You must expect a parabola. This cannot be true because you decelerate. So decelerates faster and then so you lose a lot of velocity and then just smoothly. That cannot be true. The deceleration has to be exponential, potential. So it has to slowly decelerate and then just suddenly becomes higher deceleration. Okay?
Okay.
Question A?
Okay,
Sorry,
so
question
when it describes the motion when the effects of air resistance are ignored. Acceleration is constant. It would be B because acceleration will never remain constant if there is a resistance, and it will slow down. It will slow down the acceleration. Yeah, B. I think.
So at the peak, what happened with the vertical component?
Right.
You have two components.
Yeah.
One vertical,
Horizontal.
one horizontal. So you go up, and at this moment you start.
Decrease. Yeah, you're at your highest point, and then after that you start.
But what is the value of the component they're talking about?
What do you mean?
This is you have two components, the vertical and the horizontal components of the velocity. So what happened with the vertical component of the velocity?
It decreases after that point.
To a point, and where is this point? What is the value of this velocity?
It's always at its maximum. So.
No, the maximum is here when you actually point it
Oh,
out.
the maximum. Oh, okay.
So you have a velocity in this direction, right? In the direction of the dotted line. This is the velocity. But this velocity has two components. The velocity in x and the velocity in y.
Yeah.
When you go up, so the maximum is at the beginning point. But when you go all towards the peak, what happened to the component?
So,
You're not going up anymore.
no, so there is no more. Is it equal to zero? Oh, yes, equal to
It's
zero.
equal to zero.
Yeah. Terminal velocity.
Yeah. So gravity. So you have a deceleration in the component y until the velocity becomes zero.
Zero.
So the answer must be B, because the vertical component is 0, but the horizontal is preserved. There is nothing that is stopped.
Throughout.
And this is not
That's why it's B, because it's constant throughout.
This is not true.
No.
This didn't, because the velocity is
no steps in velocity. Yeah.
And here you don't. This is not true because the horizontal velocity nothing happens. This is not true as well. Okay.
Really, that's gone really quickly. It's been 10 minutes already. Okay, so force. Yeah, B again. It's just a definition of land.
Yeah.
I've just learned the answer to this.
Yeah. It's the best definition. All of them are definition. All of them are based on equation.
Yeah.
But the best definition is just based on the momentum.
Yeah. Direction to momentum.
Okay, two components. X and Y.
I'm struggling with speed U. What's the question? Before and after? No. Wait. It's either A or B. So I've had B twice. I'm not sure if it's B again because it's had B twice in a row.
It doesn't really matter.
Yeah, that's true. It's not like yeah, I think it is B again.
B.
Yeah.
The principal system. Okay. Then you have here your component for you, and you have the other one. So you have this one and this you can join from here, right? U3 times n, and you can ignore all this one. That's a demo. And it could be alpha. So you have the same triangle. Right, so yeah, well here you have so you have here the same triangle beta, alpha, and the components. And yeah, it's actually
Yeah.
Question 11.
So an object falling in air.
This is in vacuum. So how
So
would
that's
be
in a vacuum, so it's no resistance, but there will be air resistance in C. So the air resistance will cause a slight curve. There won't be a major curve because there's not that much resistance. So it's C.
Why not A?
Because the air resistance causes a slight deceleration. Well, this is still constant, just shorter, just less.
Yeah. It has to be first. It has to be shorter. This is an acceleration instead of deceleration because look how it's the beginning. I mean, it could accelerate at the beginning and then slow down. Here is totally acceleration.
Yeah, it's accelerating. That's total deceleration, and that's still constant. But
but here is not exactly the same.
No, it's less velocity, but
there's
still no. Doesn't take into air resistance into account. So PQ length is 3 and the weight is 50. I hate these questions.
And there is also a mistake in this one. I think so.
Maybe, I think it's A.
So this is like the seesaw, right?
Yeah. I
You have a weight here, and you have another weight here. So call it 2.
There's only one weight here.
And both of them are equal. So
it won't be C or D. I know that. That's way too heavy.
So, but how do you calculate? Because you will need to actually calculate it.
I'm not sure.
So, what's the weight? So, the bar, all the bar weight.
That's 50 newtons.
50 newtons. Yeah. All the bar. But you have in this side how much of the bar?
Yeah, 2/3.
So the weight 2 here is 2/3 of 50. How much is the weight of this side?
1/3 of 50.
Well, no, because you have this also.
Oh, 1/3 of 50 plus W.
Yeah. 1/3 of 50 newtons plus W. So this is equal to W1. So we say that W1 equal to W2. So what you have here is 1/3 of 50 newtons plus W equals to 2/3 of 50. And you just have to solve for W. And they give you the value according to this is going to be from A. Should be 25 newtons.
Yeah, 20. Okay.
Our question 13.
So if right angle triangles if sides of x and y is shown, so which expression gives the torque exerted? A couple. So there won't be fx.
Why fx?
I don't think it will be.
Here is the same as this one, but these are coupled. Remember when, for example, when you have only the circle, like in the when children run about when children pulled that way.
Yeah.
So that the amount is that if it's r, so if you have calculated the radius, you put 2 times f of r. But here, how do you calculate it? How do you estimate? Here it's easy because the pivot point is here.
Yeah.
Where is, so you know the pivot point, you know that this distance is 2 times r. The force is the same, right?
Yeah. Isn't x the pivot point on this one?
Where is the pivot point?
Isn't it x?
Here, here, here.
Oh, so it's along VW.
Here? Or in the middle point?
So will it be in the middle of these two?
Here.
X.
Why not in y?
Why is it not in the middle?
Why not in the center?
I don't know how to explain.
There's actually an equation that I showed you. You put in a circle, the middle point would be here. You will need to check the mathematics of that. But here, I don't know, that's the thing. They say that is f of 1.
Okay.
But for me, I don't know exactly why, but it makes sense more.
Yeah, it does make more sense.
Models, nocturne, liquid. So 14. How do you solve this one?
So pressure, so you need to find the pressure at the top and the bottom.
How do you calculate that? So you have to run the math here. So you have 8 meters here, right? And the giant squid is 20 meters. So what is the pressure difference between here and here? So how do you calculate the pressure first? One pressure, one at a time. The pressure on the top.
So you do it for 8.
Which equation will you use? I will give you. Let's see. So what would you use?
So the hydrostatic pressure. P equals PGH.
Yeah. So you have the density. If we call this point 1 and the other point 2, so you have 2 points, P1, P2. So density, gravity, and H1 and H2. And what the only thing you have to do is to make the difference. So P2 minus P1. P2 is higher pressure. So practically what you could have is the density, the gravity, and times the difference H2 minus H1.
H1. Okay, so yeah, you can work it out.
And if you do a calculus, it's
I don't have a calculator, so I can't work this out now. But yeah, okay.
It's going to be 200. That's it. So you finish with this one?
Okay, so kinetic energy, so it's half mv squared.
So the kinetic energy is equal?
Half mv squared. So the m is 600 kN and v is 300 kN. So m is 600, v is 300. No, it's not, because that's kilonewton. You need to convert it just to newtons. So you just add 1,000 on to each one. So 600,000 and 500, no 300,000, because the air resistance is 500 minus 200, which is 300.
So how do you do that? I mean, this is a force, right?
Yeah, but it's air resistance, which takes away from the velocity.
So you have force 2.
So we have F1 minus F2.
So would you use this equation? How do you use this equation? Because how do you know the mass?
You can't work out the mass.
What's equal to the force?
So the overall force is 300.
Yeah, the overall force. Yeah, we'll calculate the overall force. Yeah, only 300 kilonewtons. But how do you get the mass then? If you want to use this equation, how do you calculate the mass?
I'm not sure any other equation I could use.
There is another equation of energy, especially kinetic energy. That is the force times the velocity.
Okay. So
if you already have 3 kilonewtons,
so you can find out. You can't find out the acceleration.
you don't need to find the acceleration. You
So
only
you do
need
for the force.
the overall force
Okay,
times
so
the velocity.
Oh, okay. Oh, okay. Yeah, I didn't see that at the top.
If you see the equations of.
So 40 times 300.
So, I don't know if it comes here.
BC. Yeah, I've never seen that before, so.
You haven't seen before, it comes in the notes.
Yeah, all I've seen used is half mv squared, that's why. This will be 3 then, 12 MW.
Yeah. So the value here is C. Yeah, 12. Actually, yes. So 312. So you, 3 times 4?
Okay, I'm starting the third one now. So 3, after this we've got one more.
So here is 30 kilo
Yeah.
watts. So the thing is, sorry, it's not energy. What is calculating here is potential.
Oh,
Power.
potential.
Megawatts.
Oh, power, yeah.
So then
Okay.
there's no potential power.
Yeah, that's why I
So
didn't
it's
realise that.
megawatts. So it's not a kinetic energy. What you're asking here is the power, which is the rate of kinetic energy.
Oh, okay. I get that now.
Okay.
I'm not sure if we'll get out to the second paper.
So remember that power is equal to work over time.
So, yeah.
There is a direct conversion between work done and
Time taken.
energy, kinetic energy or energy.
Yeah, okay.
Do you understand this one?
Okay, wait, I've tried math.
Mine is
So,
showing
approximate value of kinetic energy. C.
what? How do you know that?
There's a table we have to memorize. Yeah, I try and memorize it, but some things I don't remember.
Okay. 17.
17 gigawatts. Raising power. Efficiency. Okay.
We actually have 30 minutes left. It's not less than that because we started for 30. You calculated 45 minutes, 25 minutes, approximately 6 or 5.
How long do we have left?
35 minutes.
Okay. What overall?
Overall, yeah.
Oh, okay. Okay, cool. I'm fine with that. I'm happy having more time. Okay, so there's no. I can't remember this one.
So, ¿cuántos tienes, Tilson?
So you did 2 kilowatts of power, so that's force.
No, kilowatts.
No, that's 3.
So here is kilowatts. So we said,
Power.
so here it's megawatts,
Yeah.
the power.
Mm-hmm.
So it's units of power.
Power, okay.
So what's the question of power?
It gives you mass, and it gives you height.
I don't know what points here. Unfortunately, I don't think it is.
You don't get a lot. It doesn't give you a lot of equations.
Yeah, okay. So how do you, what's the question of power?
Power. What Fe. So P equals F times V is 1.
What is power equal to? Work done over?
What time?
Time. So work done is equal to energy. We have 2 types of energy, kinetic energy and potential energy.
Yeah.
What kind of energy is talking this about?
This is potential.
So you have your water supply here.
Yes, gravitational potential.
Yeah. You just try to do at 7 meters. So potential energy over time. So how do you calculate this potential energy?
So mgh. You do have the mass too.
mgh.
You do have the mass.
Which is the mass?
So 16. The height is 7. And gravity is 9.81.
16 kilograms.
Yeah.
Yeah, I don't have space. And so
16,
16
times 9.81 times 7 over the time.
9.01 meters second minus 2.
You're not given time.
Are you sure? 7 meters.
It doesn't.
Yeah, they give you a time.
Doesn't it? Oh, per second.
So the time will be
1
second.
Oh, yeah.
And it will give you, I don't know, a value of power, I don't know which. And in kilowatts. Well, actually, it will be watts, you just convert it in kilowatts. And that value of power, this value of power, we call it power 2. And this is power 1. You only have to do is just divide. So you divide power 2 over
Power 1.
power 1. And that's the efficiency.
Yeah.
The efficiency is always lower than 100.
Yeah.
And the result, the answer to this one is 55 if you do the calculus.
Okay.
So what about question 18?
18. Under the whole graph, it's not A, it's not B, it's D. It's work done in stretching.
Yep. So the work done. So what's the question here?
So it's asking what is the area under the graph.
Yeah, but so what the question for this is 1/2 the force times the extension.
Okay.
And this is equal to the area. You have the force,
Yeah.
the extension, and I think how do you solve question 19?
So yeah, what this is still. So still the copper ratio. Oh God, okay. What's Hooke's law again? This is B or C, huh?
But how do you calculate? It's not about guessing. It's how do you
Yeah,
calculate?
you use Hooke's law.
What is Hooke's law?
So I'm trying to remember. It's to do with Hooke's law.
So the Hooke's law talks about the force.
So the strain of a solid is proportional to the applied stress with an elastic limit of that solid. Is it not another one? It's probably an easy one.
Yeah, but the question, what are the
Yeah,
questions?
I'm just looking at what Hooke's law is. So it's asking.
The force applied is equal to the Morse constant times the extension.
Do that for copper and steel.
So the force is the same for both of them. The extension 1 and the constant 1, but also the force could be equal to K2 extension 2.
Yeah.
If both of them are still in the elastic limit, so what you have to do? Just equal it. So K1 E1 is equal to K2. You have so what I ask if
start.
So if the extension is,
So 25 minutes.
if the extension of the wire, so they're not asking you exactly the extension, they're asking you the ratio. So we would say that one is the stainless steel, so it's E1 over E2. So what you have passed this one down and this one down. So it's equal to K2 over K1.
Q1.
So again, E1 over E2. And so say K2 is copper, right?
Yeah.
And it gives you
If you could
K2 modules.
still is twice of copper.
So
Okay. Okay.
K2 twice K2 or half.
Okay. So it's 2 to 1, so it'd be P.
Okay.
Oh, always. Yeah, always can be observed by Doppler shift.
All types.
Yeah.
What about this one? I think I have an issue with that one because I was trying to correct some of the things.
I've not been taught that much about stars, so.
I don't have How do you calculate this one?
I can't remember. I've not done that much on stars. I don't know about the frequency and stuff. Doppler effect, formula.
So what is the effect Doppler?
Doppler effect.
Yeah.
Further away, the more stretched the wavelengths are. So the further away something gets, the greater it is, the more stretched its wavelength is. So,
Writing down the question.
so 21.
So what happened with the waves when they approach and when the object approaches to you?
So when it approaches, the wavelength will increase the closer it gets.
What will happen again? When the object approaches to you?
Its wavelength will decrease.
The wavelength decrease. The frequency?
Increase. No, decrease. Yeah.
Oh, forget the wavelength. The frequency is the most important part.
The frequency decreases.
Yeah, because we should have the... When the object approaches to you, the frequency?
It increases.
And when the object is going away from you?
It decreases. Okay.
So how would you start solving this one? Which data you have?
So you have the frequency, the speed, and the speed of light. Not sure how that helps.
The speed of
Light and that and the overall and the speed of that it's moving at. The velocity.
That you have let me see. I don't think you have the question for this one. I'm not looking the question exactly. No. Want to see the nomenclature? Okay. So here we'll call it yes. And it will be 1.40 tons at the same meters per second. You have the frequency. It's 4.57 times 14 hertz. And the speed of light, c, 3 times 10 to the 8 meters per second.
Bless you.
Thank you. So, then how you relate these things? How do you calculate? It's just a simple relation, actually. The V over C.
Oh, like 20 minutes.
The V over C is equal to? What do you expect? Increase or decrease?
Decrease.
So you already have. So what do you expect? What is happening here? So that what is doing the star? Moving to the Earth or moving away from Earth?
That's moving. If it's receding, it's moving away from the Earth.
If
So
it's
it would increase. No, it would decrease because it's going on moving away.
you will have two frequencies.
Yeah.
Okay. So practically what you will have to calculate is this frequency. And what will you do is you separate from this relationship. So the FPS over C. No, I don't think so. Okay. I'm making a mistake. Yes. Sorry. Here sorry. So the question says that the frequency of the observer, so the people on Earth, will be equal to the frequency of the emission times the velocity of the emission times the velocity of the medium plus minus
Yeah.
the velocity of the emission. So the velocity of the medium actually is c. So not the emission of the or medium is c. That's the speed of light.
Yeah.
This is the frequency of the emitting wave. That is the actual. We have the 4.57. So 457 times 10 14. Actually, this is. So this is here, not. This is C again. So it's 3 times 10 to the 8 over 3 times 10 to the 8. So it's plus or minus?
Plus.
Why plus?
But
So
you do how many other?
What this equation is telling you is that the frequency of the waves, the speed of the wave in the medium is going to be affected by the speed of the moving object. So if the moving object is going away from the observer, so you have to add or subtract the speed to the medium.
It's subtract.
So what happened here, for example, is the frequency of the observer is equal to the frequency of the object. If the object is static, so for example, C would be C over C.
Yeah.
Okay. And the both frequencies will be, this will be equal to 1, and both frequencies will be equal.
Equal, yeah.
But what happens if we said that if the object is moving towards you, this frequency must going to be?
It will increase.
And in order to increase, I have to
increase this.
No, if I increase
this,
so I would have to raise the velocity.
But because it's
receding,
it's going away, so it'll be plus.
Plus, exactly. So
okay, I understand that more now. Yeah, I didn't get that before.
And that's what the question is telling you. And here, I didn't write down the answer, which is 20, right? Well, yeah. So you do the calculus, you will have the question. What about the second one, the 22nd?
So X has a...
You have two waves.
Of Y, okay. So the frequency in Y is half the frequency of X. But yeah, it's half because it's half as many.
For the amplitude?
But the amplitude is double, yeah. It's double in size. So it'd be B.
B. Yep. There is always a relationship between both of them. If one is half, the other half to be twice. In order to be
opposites.
So what happened here? So it's telling you. So the velocity of the both weights is the same. So if you have one, you have to actually multiply the other one, and you will have both velocities. Okay, 22.
Okay, so what now? Is it? It's A, yeah. So where it's A, definitely. Yeah.
Because of
there's no other choice really.
Yeah, which it could be D.
Yeah. Which of these is correct? No, it's correct. It's not C. It's not D. Yeah, it's not A, it's B again.
Yes. It's B. ¿Cuál es el otro? Por favor, ya. 25?
25. It's a weird question. I have no idea. This is a weird question.
It's still the same thing. So, but
I don't know the exact what ones it would be.
So it's here it is, you have your instrument. And the question says, a musician maintains a stationary sound waves with a node at the mouthpiece and antinode at the other end.
It will be high, it will like increase by a lot, so it will be
Which
one of the
different
bottom
levels of
two.
the sound can be produced by the bubble?
It will be one of the bottom two. No, it increases a lot.
Second?
I know that the further it is, the more it increases, so. Or pretty much triple.
The thing is, you have to actually solve here. If it, what is this? So here is your beginning and your end.
Mhm.
So what do you have here, a node or an antinode?
So yeah, antinode.
Antinode. The node is this one. So you have here the opposite. I think one of the ends is closed. And then you will and here you will have the antinode. You will have here the node.
Yes.
Yeah.
So,
Let's pass this one. I'm not
yes, it's
sure
a
about
weird
it.
question.
No, I mean, yeah. I need to answer the question because I don't have all of them at my mind. The question is supposed to be the, which is not second. Because it's a second node, it's a first node. Oh yeah, first node. Second harmonic, first harmonic. I don't know the full equation. Let me take this one. I remember all the equations, so the first and second harmonic. So 26. So you have a monochromatic line going on.
Okay, so I don't know if it's. I've not done these sort of questions too much. I don't know what a maxima is.
How would you solve it? You need a specific equation.
There's an equation for it.
That's a question, yeah.
Okay, I don't know how to answer this question. I've never seen it before. I don't know what a maxima is.
So there is a very, very specific equation of diffraction. But what equation do you think you should use?
I'm not sure.
Let me see. Can put it two ways. So if I give you this, how will you solve this then? Which value do you have here?
So you have the wavelength and you have the angle. with angle of the first fraction, or the first order maxima. So you have theta and wavelength. You need D and N.
This is called the Bragg equation.
Okay, I've never heard of that before.
You have already the first order. You have the wavelength. You have, you don't have the distance, and you have one angle.
Mm-hmm.
But also they ask you, so what is his number? It's 1, because they call you. So it's a monoid light wavelength. So what I'm asking you here is, you have a crystal. So you put monochromatic radiation, it's usually X-ray. And when this radiation diffracts, it diffracts in a very specific angles. And you put this in the middle, so that this angle that is mentioned, the 15.4 degrees, this is called the first.
Okay.
This one, the other one is called the second order.
Mm-hmm.
And in theory, you put here just a line. The distance from here to here is the same to this and to this.
Okay.
So you have n lambda equal to 2d sine of theta.
Okay.
And if you divide by the second one,
Yeah.
and lambda is going to be the same,
Yeah.
2d sine of theta 2. So the distance, the 2, and the wavelength, right there, they just disappear.
Mm-hmm.
The only thing you have to calculate is the second angle.
The second one, yeah. Then you can find the angle which is between it.
Mm-hmm.
So, yeah.
Yep. You're using the right equation.
So electron, which direction will accelerate the electron? That'd be D. If the field's going that way, yeah, it will accelerate it.
It would feel accelerated?
Yeah, if it's D. So if it's in direction D.
In direction D.
Yeah.
So it's going to be opposite to the electric field.
Yeah.
So it would be repulsed.
Mm-hmm.
Please. Yep. Continue.
Force on an electron. I don't know.
The electric field is strong of a certain distance from an isolated alpha particle. What's an alpha particle?
An alpha particle is 2 protons, 2 electrons.
Mm-hmm. The force of an electric field. So you have.
Just this last question. Finished.
Yeah. So I remember. So what do you have? So you have one particle here and other particles. So Q1 and Q2.
Mm-hmm.
Mm-hmm. You will have here a constant K between Q1 and Q2.
Mm-hmm.
Twice the R. So the distance between.
Yeah.
Sorry, the square root of the distance of the particle. So the only thing you have to multiply is the charge between both.
Okay.
Times this constant.
Yeah.
Times the distance, and then you will have
The answer.
the answer of the force over.
Okay. Yeah, we've run out of time now.
Yeah. So you have 29.
Okay.
Yep.
Yeah. Okay.